kita ingin menjemput Dr. Kok Gin Xian. I hope I pronounce your name correct. Seorang data scientist daripada Inmagine, dan beliau akan berkongsi dengan kita presentation yang bertajuk Menilai Kecantikan Gambar dengan Deep Machine Learning. Wow. Okay, dipersilakan doktor.
Good morning, ladies and gentlemen. My name is Gin Xian. Today, I will share my experience in how you can build a deep learning model for rating images. Ladies and gentlemen, let me ask all of you one question. How often do you visit some online shopping site looking to buy something only to end up not finding what you are after? Or you find what you are after a very long search? At 123RF, with over 120 million images in our collection, what I have just described is a very real problem for us. Hence, at 123RF, we place a lot of effort in our search engine to make sure that the users can find what they are after easily and quickly. Please allow me to introduce my company. So I am a data scientist at 123RF. So we are part of the Inmagine group of companies. We are founded in year 2005, and we sell royalty-free stock images. Besides images, we also have vector graphics, icons, fonts, videos, and audio files. So what is royalty-free images? So it is a type of license that is used by stock agencies like us to sell images. This type of license grants the users a set of rights for a one-time flat fee. It means that you buy the image once and you can use it forever in whatever ways that you like. We use a lot of AI in our company. Among them are automatic image cropping, layout design suggestion, image tag relevance evaluation, image contrast enhancement, visual search, automatic image colorization, automatic background removal, font recognition and similar font recommendation, and image aesthetic tool. But today, I will bring your attention to two of these AI tools, that is visual search and image aesthetic scoring. Why? Because they are used in our search engine to make users find what they are after easily and quickly. So what is visual search? So it is a feature that allows users to quickly find similar image to a query image. On your right, we have an image from our collection. So for example, if you suddenly decide that you want to find more images of the handbag that the lady is carrying, you can easily use the visual search feature. So you just draw a bounding box around the handbag, and our search engine will return to you all images that are similar to the handbag. So then next, you like the trousers? No problem. You just draw a bounding box around the trousers, and our search engine will return you image results from our collection that are most similar to a trouser. So, since this is a image slide, so I cannot do a live demo, but feel free to try yourself this feature at the following website, www.123if.com. Next, I will talk about image aesthetic scoring or classification. So this problem asks the following question. Given an image, how aesthetically pleasing is it? Or how nice is an image? So for example, this image. Do you like this image? Do you think this image is nice looking? How about this one? I'm not sure about the previous one, but I'm sure all of you will agree that this is not a very good looking image. So why is image aesthetic scoring important for us? Like I said, we have a huge collection of images. With over 120 million images, it can be difficult for users of our website to search what they want easily and quickly. With an image aesthetic model, we can score all the images that we have, and then we present the nice looking images to the users first. So finding an image from 120 million images is like finding a needle somewhere inside. So there are 3 simple steps that you need to build an image aesthetic model. First, of course, you need to have some data. Second, you define your model. And then 3, you train your model. So step 1, how can you get your data? So there are 2 steps. There are 2 different ways. One, you can find some publicly available datasets on the web, such as AWA dataset, which contains over 220,000 images. There is 30 gigs of images. There's also other datasets like CHUPQ with over 70k images, AADB with 10k images. Or those of you who have web scraping skills, you can get this kind of data online using your web script skills. So these are some of the sample images from the AWA dataset. On your left, we have some top-rated images. On your right, we have some bottom-rated images. So there are 2 ways we can approach the problem. We can think of this as a regression problem where we give a score to an image, 0 to 1, or 0 to 10, or 0 to 100. Or we can treat this image aesthetic as a classification problem. We give a class and a probability of a class to an image. Is the image good or is it bad? So in either case, for images, usually we use what is known as a convolutional neural network, or CNN. So this is a CNN model for regression. The center part of it is the neural network, and it consists of the backbone or feature extractor, fully connected layers, and then the output layer. So basically, you give an image, it will give you a prediction. So during training, the weights will be tuned to improve the prediction over time. So the activation of the final layer for regression, we use a non or linear activation. For a loss function, we use what is known as the mean squared error. So for the CNN model, as you can see, there is really not too much of a difference between these 2. The only difference is that you use a different final layer activation, and you use a different loss function. Okay, so how do you build the backbone? Or how do you design what to use? So my advice is use a standard architecture pre-trained on some existing dataset. For example, existing architecture trained on ImageNet dataset. ImageNet is a large-scale image dataset with over 14 million images. You can also make use of the table on your right to help you make some decision. You can use the ResNet 50, which is a good starting point as it is not too difficult to train and it offers great performance. So after we have the backbone, then we add fully connected layers and the output layer. After that, we compound the model and then we can start training. So the admin, can you change to the additional content that I've given just now? Admin, controller.
Admin, tolong. Ambil masa sikit Ada isu ke admin? Ada isu? Okay, Doc, mungkin you nak proceed dulu ke slide seterusnya? Dan kita boleh go back.
I think this is the final already.
Oh, okay. Okay, sementara kita nak menunggu daripada kita punya technical team, boleh kita minta soalan? Soalan daripada apa? Peserta-peserta? You all sekarang? Yap. Mana mic ya? Mic. Okay.
Hi, Doctor. My name is Shah from around here.
Okay, can we...
It's on.
yeah, it's on.
Okay, sorry.
Okay.
Hold your thought.
On hold.
Kita pause
Alright.
sekejap.
Should I hold the mic to
Yes, you can hold the mic. Yes.
Okay.
Yeah, Doc.
Okay, since this is a technical sharing session and a lot of us here are developers, so I have prepared some coding and we'll go through how you can train your own model or deep learning model for making predictions. So first we install some Python dependencies. I'm making use of several libraries, augmentations for data augmentation, OpenCV for loading and manipulation of images, Seaborn for charting, Keras for building models, and scikit-learn for some utility functions. Then we define some, then we do the imports and we define some configurations. Here is where I store my data set. Okay, HWC is the height, width, and channels for the images. Then we have the learning rate, we have the batch size, we have the workers and the epochs. Because when you train a neural network, usually due to limited resources, you train in batches. Please scroll down. Okay, here is the function to load an image. Scroll down further. Here is the code for loading your data to be fed into the neural network. Please go down further. Here is where we do the data loading, preparation, exploration. And here is what the data looks like. So we have image ID for each image. We have a distribution of all the ratings. For example, for the first one, image ID 953619. How many people give it a rating of a rating of 1? How many people give it a rating of 2? How many people give it a rating of 3, and so on. And here is how the rating mean distribution looks like. So we have about 255,000 images, and this is the distribution of the rating. Next, we do some model definition and training. Here is how you define a backbone. Let's scroll down further. Let's scroll down further. Let's continue scrolling. Okay, pause. Okay, so we have defined the backbone. Just now is what the backbone looks like. So then we define fully connected layers and the output layers. And then we, scroll down. Scroll down, please. Yeah, and then here is how we prepare data for training. Here I have did a sample. So we, instead of using all the 255,000 images, I'm only using 2,000 images for this example. Please scroll down. So data augmentation is how you modify the data to generate even much more data. The idea is that because neural networks, they perform better when you give it more data for training. And we don't want the neural network to only memorize the input. Yeah. Please scroll down. This is an example of data augmentation. On your left, we have the original image. On your right, we have the augmented image. As you can see, it is flipped and rotated. Please scroll down further. Please scroll down further. Please scroll down further. Okay, then now we compile the model. And this is how the model looks like. This is a summary. And then here we start training. Please scroll down further. Okay. Here, after training, we can plot out the loss. And then we plot out the metrics. After that, please stop. After that, after we have trained our model, we can use it to make prediction. So, for example, go down, scroll down. Okay, for this image, we made a prediction for it. And as you can see, it achieved a score of 4.427 out of 10. Okay, I think I better stop here. That's all from me. Any questions?
Yes, kita boleh teruskan dengan soalan tadi.
Hi, Doc. Thanks for your insight. Two questions from me.
Sorry. Okay.
One, is there any specific reason why you execute the project with keras as compared to the other alternative? Second, I assume this is for your internal use for 1, 2, 3F teams. Any plan to make an API? Typical question from developer.
Actually, you can build machine learning models using any of the available frameworks. For example, Keras, PyTorch, TensorFlow, Fast.ai. You can use any of these. But because Keras is a very simple model, and it have a lot of functions already implemented, so you can quickly build your own model. And with a high-level library like Keras, it allows you. The probability of you introducing errors will be less. Okay, and for the second question, currently we are building this model for our own use. Of course, we will, even for our own use, we will be, after we have the model, we will deploy it, and we will have an API for it, but the API will be internal only. Yes.
Okay, ada lagi pertanyaan? Ini topik yang sangat menarik sebenarnya, machine learning, mesin yang belajar. Ada apa-apa lagi pertanyaan? Saya rasa lepas ni mungkin kita kena keluarkan peribahasa yang baru lah kot. Jangan menilai seseorang daripada melihat paras rupa, tetapi kita boleh menilai seseorang dengan menggunakan machine learning. Wah. Khusus untuk developer sahaja. Okay, ada lagi soalan tak? Okay, yes. Minta tolong bagi sebutkan nama dan berasal dari mana ya.
Hai, saya Amizi. Saya nak tanya, you punya dataset yang you train tu, you sharekan ke ataupun you just untuk your own use?
Like I showed earlier in the slides, so there are two ways you can do it. So you can use publicly available datasets that you can find online, or you can by crook or hook, you get the data yourself. For example, you can do web scraping. For example, there are some photography sites that post competitions, and then the photographers they post they submit their photos, and then all these photos they participate in the competition. So people give it ratings, and then maybe you can collect those photos, those data.
So your dataset on the.
So you mean for the one we use internally?
Yeah.
We get from online sites using web scraping.
Okay. Your dataset currently since the topic is beautiful, right?
Yes.
So your rating based on what I see, a bag, something like that, and then I think I could see the first person, and you that you're already trained, maybe the local face, something like that. No.
So sorry, I didn't get your question.
Okay. Never mind.
Saya rasa mungkin saya boleh bantu. Soalan dia, correct me if I'm wrong ya. Sebenarnya bertanya kepada macam mana kita nak train you punya machine tu untuk lagi efisien dan juga lagi tepat menggunakan sampel-sampel lokal. Betul Ya, gambar-gambar yang lokal lah. Bermaknanya kalau kita nak train untuk recognize kita punya ASEAN punya muka, jadi macam mana sampel yang digunakan? Have you dah ada ke all the samples ataupun macam mana? Ataupun should we contribute our face untuk you develop machine learning dan we charge you lah? Kan?
Okay, because data collection and gathering is a very labor-intensive process. So usually we try to find data sets that are already available online or somewhere outside. So if we cannot get it, then we will try other methods. Like I said, maybe you can buy the data sets, or you can use, for example, you can use AWS Mechanical Turk to use their service and then ask them to do the labeling for you. Or you can go to use your programming skills to scrape this kind of data from the web.
Okay, just nak tanya, siapa yang involved dalam data analytics? Tengok tangan. Ramai tak? Just nak tahu je. Sama ada ramai ke tidak? Data analytics yang involved dalam machine learning, AI? Okay. Ada apa-apa pendapat, pemandangan yang nak dikongsi bersama? Pandangan. Minta maaf, hari Sabtu belum makan. Ada apa-apa nak kongsi tak? Sebab kita punya doktor, yes. Satu lagi soalan, tolong. Ini peluang keemasan sebenarnya because jarang kita boleh mendengar apa-apa pandangan daripada pihak industri dan doktor juga daripada UTM. Jadi memang bagus peluang ni.
Hello, Doctor. My name is Irfan. I'm from Hermo. Hey. Yeah. So I understand that doing machine learning, deep learning requires a very expensively and costly hardwares, right?
Yes.
So in order for you to do that, so do you have any suggestion for all of us here who is an amateur in data science to actually start with a more effective cost, or maybe a free one to do this, or whatever it is that you suggest? You suggest, yeah. Thank you.
Okay. Maybe you can make use of some online services, for example, like Google Colab, because they offer some machine time that you can use freely. Or maybe if you want, you can use you can build your own PC with some graphic with NVIDIA graphic card. For example, you can buy a graphic card like on 1111 cheaply.
Hin.
Yeah, I think that's the two advice I can give lah. Sorry. So at 123F, there are two ways we do it. So we either use online services. For example, we use AWS EC2 or AWS SageMaker. Or we also, at 123F, we also have our own PCs with multi-GPUs. Yeah. So that's how we do it.
Okay, selain daripada soalan apa benda yang boleh dipakai secara percuma, ada lagi tak soalan-soalan lain yang mencabar? AI, machine learning, analytics, tak ada?
Okay, hello, good morning, Dr. Kok. So, the next fellow asked about cost, but for us, like we are programmers, but for machine learning, data scientists, there's a lot of mumbo jumbo things that, like when you want to start, we don't know where to start. So, like there's things like Bayesian, there's things like aggregation. So for us that is not totally zero, but we have coding experience. But we want to jump into machine learning. What do you advise? In which point should we jump into? So the steps are getting started steps.
Okay, I believe there are lots of resources online. that you can follow. For example, there's a good machine learning course by Andrew Ng on YouTube. And then also on other e-learning platforms like Coursera. There's a lot of courses you can take. Also, there's a platform called Kaggle that you can participate, because that's where a lot of data scientists or data enthusiasts, they post their work there. And there's a continuous feed of all the works, and then you can go through their codes to understand what's going on. Yeah, these are the few advice from me.
Okay, that is satu tip yang sangat betul, because kepada data scientist ataupun siapa-siapa yang berminat dalam analytics, ya, memang ada satu website yang bernama Kaggle, kaggle.com. Jadinya dekat situ memang banyak kod-kod yang berguna untuk kita buat sebagai rujukan lah. Jadi mari kita berikan satu tepukan untuk doktor yang sudi berkongsi sesi untuk hari ini, ya.